Okay, so the next few operations are going to be done on the mill here. Hopefully we've got enough lighting so we can see everything. The first thing I'm going to do is I'm going to take this, the main lower body, and I've got to drill and ream a 1/4 inch hole in here for the gas valve to pass through. It needs to be pretty accurate because that gas valve will go through there and have a hole, a cross hole in it, which will allow the gas to come out of this threaded hole, which will have our 6,000 size gas jet in it. So I'm going to set this up in the Bridgeport vise here. Got a parallel against the back jaw to hold this at a height where I can work on it. So I'm going to use my edge finder with my digital readout, which I repaired in a previous video in case you're interested. I'm going to find the center of this piece. I'm going to find the bottom of this piece and come up 280 thousandths, drill and ream a hole. So I zeroed out my x-axis digital readout there. And back to the other side. Find the edge of this edge. Zero out on here. Once I find the edge of this, I should say. That, and I'm going to use that half function on my digital readout. Set this on center. Right there, so that looks pretty good. Since the bottom of this is up against the positive jaw, find this positive jaw location will be the same as the bottom of this piece. So I'll move this to the back vise jaw, which is the same as the bottom of this part. When it kicks out, it'll tell us where the, there, got one more time, right there, zero the y-axis. Now the tip on this edge finder is 200 thousandths. So I'll go move my y-axis 100 thousandths, half of that diameter, 100 thousandths, and I'll reset 0. So now my y-axis is zeroed on the face of this vise. X-axis is centered on the part. Bring X to 0. Y, and we'll move to 280. And that'll be where this hole is going to be. Just take a quick look at it. That's why I only put a parallel on the back side of this part instead of both sides. It's relatively short, so it'll sit pretty square on that jaw, and the parallel on the back will give it some support, but if I put a parallel on the front, I'll hit it with the drill when I come through. Let's do this a center drill. Okay, so that center drill is broken through to the hole in the middle. Change up for our drill chuck. So this drill chuck this drill I'm installing is just smaller than 1/4 inch. So it leaves some stock for reaming. Okay, I slid that parallel out of there. I was kind of concerned with hitting that with that drill bit. Swap this drill bit out with the reamer. That's the whole drill and ream through this body for the gas passage. The gas valve body. Off to the next part. So now I'm going to drill the cross hole in the valve body here, so that way the gas can come in the hose bar, which you can't see, and it'll turn 90 degrees and go out the side and go up the lower body of the burner. So we'll start by finding the center of this, and then the hole is going to be 312 thousandths off the step where the hose barb is. Half function, which will set Y to the middle. Zero for X. Move over 100 thousandths for the radius of the edge finder. 0x again there. Okay, with the center drill loaded up in there, move 312 thousandths over. I'm going to reset 0 there. This is the only hole in the drill, so that way it's easier to come back with the drill bit. Lock everything down. Center drill it again with my slightly too large center drill. So once again, I've got a chuck and a chuck here. So I've got my small hole drilling adapter in here so I can feel when this small 1/16 inch diameter drill breaks through into the main cross hole. There it is, go through into the center hole. So that gives a cross hole for the gas to come in from the hose and out this hole, metered by the needle valve, needle jet that goes in here. So this is the 90-degree head for the burner. This is the item that is different from my previous build. So I'm going to start by locating the center of this larger diameter. I'm going to drill and ream 3/8 hole, not quite all the way through. I don't want to break out the other side. So I want to be pretty precise on this depth. This drill is just under 3/8 of an inch. There's enough stock for the 3/8 reamer. So I'm going to start by moving my quill down, sit on top of the scale. The scale is 35 thousandths thick. And I'm going to set my hard stop on the quill using gauge blocks to get the correct depth. Okay, so that drill point just met up with the cross hole, just as planned. I'll put a reamer in it. So this will be similar, but I don't want to run this reamer all the way down to depth. I want to use it to create a slight shoulder in there, difference between the drilled hole and the ream hole. That way it'll give something for the vertical venturi to sit on it, and it won't slide all the way down and block the cross hole. So do the same thing. I'll start by setting this on top of my scale. But now I only want 100 thousandths depth of cut on here, so I've got a gauge block that has 100 thousandths plus the thickness of my scale. So it gives us a cross hole in there with a slight shoulder for the end of the venturi to sit on. So that only leaves a couple more pieces to make. There is the main tube that goes in here that holds everything together. It holds the venturi down to the main body, which is screwed to the base. And as you see, there's this air regulator, air dampener on here. Both these pieces are made out of brass tubing. These require us to drill some holes in them, cut them to length, and then we can start some assembly. So in order to perform these operations on this brass tubing, round brass tubing, I've got to drill some holes 90 degrees apart on these. A good way to hold round tubing in the mill is with a collet. So I've got this square collet block. I'm going to have to drill 4 holes 90 degrees apart. Well, squares are 90 degrees, so that'll work for that. So I've got a 13/32 collet in here to hold this brass tubing. We go in here like this. Now I've got a vise stop set up so I can insert and remove this collet block, and it'll repeat in position. I'm going to set this probably about a 1/2 inch or so. So I'm going to find the center of this, find the end. I'm going to come in from the end, 122 thousandths, and it's going to need 4 holes, 93 thousandths diameter around the perimeter. Since you've seen me edge find quite a few times in this video already, I figured I'd show you the operations of the digital readout. Hopefully I don't run into the tripod here. So first I'm going to approach looking to center the y-axis on the center of this brass tubing. So I'm going to approach one side of the brass tubing until my edge finder registers. I'm going to set that to 0. Retract my spindle, you can't see it here, move to the other side of the brass tubing, I'm going to find the second side of my edge finder. Now I'll use the half function. 1/2 Y. So that took the first spot, it was where I zeroed. And the distance to the second, I divided that in half. As you see, it was 606, now it's 303. So now if I move my y-axis to 0, I'm in the center of the branch too. Now I'm going to take my x over, find the end of the branch tube. Same thing, I'm going to go until I come up against the end of the tube. The only difference here is that since I'm not using the center line, I have to remove 1/2 of the diameter of the center finder. The end of the the edge finder, I should call it. So this end of this edge finder is 200 thousandths wide. So the radius is 100. So I move over 100. That puts the center of the spindle right on the edge of that part. So then I reset the x-axis to 0 now. And that puts the center of my spindle right on the edge of this part. So now I know that the y-axis is in the center of the tube, and the x-axis is zeroed on the end of this tube. So in order to drill these holes, now all I need to do is move my x-axis over 122 thousandths and drill the holes as needed. So now I put my center drill in, I move the X over 122 thousandths, and that gives the location of this hole. I'm going to center drill this side, put my drill in here, I'll drill through both sides, flip this 90 degrees, and do that again for the second set of holes. So after I moved 122 thousandths, I did re-zero my digital readout, so that way now I don't have to remember the numbers. I can just return to 00 after I switch between drills if I have to move any axes. Now I can move my X over, change my drill bit, and I don't have to worry about losing position. Drill out. So now with this collet, this square collet block, to do the other pair of holes, all I need to do is take it out, rotate it 90 degrees, push it back in against my stop, and it's ready to go for the second set of holes. That is that. I'll take this over, deburr it. I will put this in the lathe, cut it off to length. Let's start on the next piece. So I've got this already loaded up as before. I've zeroed out my Y-axis to be on the center line of the tubing, set my X-axis to the end of the tubing. This time I've gone in 285 thousandths from the end. I'm going to drill a hole in here. This is what is going to tie this together with the main body and the valve body. So this will eventually get reamed a 1/4 inch. I'm going to drill it just slightly under and then ream it all as an assembly. But first, let's drill this hole. Very gentle, this big drill will grab the walls of this tubing and tear it all to pieces if we're not careful. I'm going to want to drill 4 holes in here, which that air control ring will go over that we just finished making before this. We'll drill these just like we did the air control ring. Okay, so that takes care of this part. Same as the last one. I'll go take this, deburr it, we'll put it in the lathe, cut it off to length, and then this will be ready for assembly. That should about do it for the work on the Bridgeport.